Everybody, let's practice drawing some other molecular orbital diagrams for some other simple molecules. So let's try to draw helium-2+. Now if you look at a periodic table and you look up helium, you'll find the electron configuration for helium is 1s2. Alright, so we're going to have energy diagram. We're going to have a single helium atom using its 1s orbital. We'll have another single helium atom using its 1s orbital. It's helium-2, there's two of them. So this is helium number 1, if you will, and then helium number 2, if you will. We're going to assume that one of them has both electrons. And if this is overall plus, then one of them is going to be missing an electron. So we'll have that. Now remember that these two orbitals, when you combine them, they can add and subtract to make the new molecular orbitals. This would be my sigma, my bonding. It's made with 1s. And then equally a pi. This would be my sigma 1s star to reflect the antibonding. Combined, I've got 2 electrons here, 1 electron there for a total of 3. So I'm going to go 1, 2, and then there's my third electron there. Just a quick little count here on bond order. You can do bond order, remember. It's 1/2 the electrons in the bonding molecular orbital. That's 2. Minus those in the antibonding, that's 1. So this is a 1/2 bond order. So helium-2+ does exist. It's just it's less than a single bond, so it's not incredibly stable, but it does exist. Now here is the actual prettier version of that diagram we just did, where we did helium-2+. Now let's try another one. Let's do helium-2 now. So again, single helium atom, we're going to use the 1s electron orbital. Single helium, we're going to use the 1s orbital. We've got 2 electrons each. It's helium by itself. It's 1s2. Take my sigma 1s, my bonding molecular orbital. My sigma 1s star, bonding molecular orbital. Now I've got 1, 2, 3, 4 electrons. I've got 1, 2, 3, 4 electrons. Let's calculate the bond order. 1/2, 2, and bonding minus 2. Oh, this is 0. So this one's unstable. So helium-2 does not exist. And again, there's the picture taken from a text. It shows the same picture we just drew. And then we could draw 2 more examples. We could draw LI2 and Be2. You should pause the video here for a second. Draw those 2. Which orbitals would those atoms be using? Notice lithium-2 is 1s2, 2s1. So we're going to focus on the valence electrons to do the molecular orbitals. So for lithium-2, it's going to use a 2s. And then beryllium-2 is 1s2, 2s2, again using the outer valence electrons. Notice Li2 has a bond order of 1, so this is stable and it would exist, whereas beryllium-2+ has a bond order of 0, so this would be unstable and would not exist. There you go, some more simple diatomic molecules in molecular orbital theory.